Hello there. This is a quick overview of the PrintShift parts. This is basically just going through the bill of materials visually, because some people don't know a lot about this. The point of PrintShift is that anyone can build it, so if you know what the parts look like, if you found the bill of material on the GitHub, you might not need to watch this, but feel free. Alright. First step in building PrintShift is lifting the Prusa Mini's belt up, so we have hex standoffs. This is a 4.5 millimeter by 10 millimeter long hex. 5 millimeter hex would be better, but I wasn't able to obtain. It has a 3 millimeter thread. Second thing, there are 6 flathead screws. It's an M3 thread screw, 8 millimeters long. You could reuse Prusa's original ones that use a Torx drive, but I'd rather replace them with longer ones, so I do. First printed part we need is actually a modification of Prusa's part. This is the heat bed cable cover. It's shorter on this side so that we can fit the belt tensioners in. I have a couple of these 8 millimeter shaft collars, but I've been assured that the shaft will not walk, so these are not necessary. To mount the motor on the idler, aside. So the first thing you need is a 20D metal gear motor. This is a 6-volt motor. Has a gearbox on top that's 488 revolutions of the motor to 1 revolution of the output shaft. Output shaft is a 4 millimeter D shaft. I'm gonna open this up just to show you what's inside. I feel like if you're building this, you're hopefully mechanically curious. So this is a whole stack of spur gears. Side carefully so we don't lose any. If you look under here, even more spur gears. I guess this shaft is in the other. Okay, so I'll have to rebuild that slowly. If you open this up, you can see these guys all slot together nicely. The back of the output shaft, you can see that spinning there, is housed in the center hardened steel bushing. So it is supported, although it's quite short. These alternate. And then they all mesh. There's a brass spacer in this guy. You can see the motor's output there. So the motor output turns gear 1, in decent focus. Gear 1, 2, 3, 4, 5. I don't want to take it out to show. $20D, it's 20 millimeter diameter. In order to mount the motor, we actually have 2 screws that look a lot like these. But they are not the same. These are 12 millimeters long, a little longer. And look at the diameter. The motor mounting screws are 2.5 millimeter diameter. So M 2.5 screws. I know, I wish the motor used the 3 millimeter like everything else, but it doesn't. Just bought this part, so. What are you going to do with it? You need 4 of these bearings. There's actually going to be 2 for the drive shaft and 2 for the output shaft. Theoretically, if you have the bearings, the shafts won't walk, so the shaft won't come loose, and you do not need 8 millimeter shaft collars. This is just a clamp. Well, really, just a set screw. But these bearings are 8 millimeter inside diameter, 8 millimeter shaft, 12 millimeter outside diameter, and 3.5 millimeters thick. You need your pulleys, 4 millimeter shaft, 16 tooth pulley, fits on the motor. We're actually going to be mounting this with the belt closer to the motor, which gives you a little less torque on the shaft. If we mount out here, you can bend it. And these shafts are not super strong in there, so. You also do need 2 set screws for the pulley. They almost always come with them, and those are just to lock it onto the D shaft. To go onto your drive shaft, 8 millimeter 40 tooth GT2 pulley. To link them together, a 110 millimeter GT2 belt loop, continuous loop. So this is 55 teeth because GT2 is 2 millimeters per tooth, 2 millimeter pitch. You need two 8 millimeter by 200 millimeter steel shaft. Pick the 200 millimeter because it's a very common size, easy to obtain. You'll notice we have black rubber sleeve on here. This is EPDM rubber. This is actually 5/16 thick. 5/16 is basically 8 millimeter. You can also get 8 millimeter. It's about 1.5 millimeters thick, or 1/16 of an inch. You can use down to 1 millimeter. Thinner would be just fine. Thicker it starts getting away. The printed parts, you have your motor mount. Motor mounts in here with your two bearings attached on there. The drive shaft mounts on here, and this mounts on the Prusa Mini. On the other side, this is the direct mount idler lifted bushing. So this mounts on the front corner of the Prusa Mini, holds the bearing, holds the other end of the shaft. I have the parts arranged by when they're used, sort of together. In order to tension the belts, we have these belt tensioners. This is mounted on the Prusa Mini in the rear and the front. You'll note that these two parts, the plastic parts, are mirror images of each other. So when you print them two mirrored. This guy slides in and is guided by the hex standoff we saw before. Becomes a tensioner when we stick a nut, an M5 nut in here, and a 20 millimeter M5 screw in here. So we'll be holding the shaft in there. And when we tighten this, we move the shaft outwards, plus tensioning it. So, two M5 hex nuts, and two M5 screws 20 millimeters long, plus 4 printed parts, the tensioner body, and the tensioner rod holder bearing. You need 2 normal and 2 mirrored. Next to the control system for just printing off USB or for doing straight G-code. Microswitch. This is a 10T85U, 5 amp, 250 volt, the roller lever. You need the Microswitch mount. So this is actually going to mount on your Mini. Oops. Right in the 3030 T-slot. In order to mount it there, you need a 3030 T-nut. I'm using one for an M3 screw here. It's very easy to print the drop-in T-nuts as well, using a M3 hex nut instead. The only other thing I have in here are these heat shrink cable wraps. So this is sort of like heat shrink for a regular wire. There's actually solder in the middle here. So if you use a heat gun, you can stick this right on your terminals of your switch. So you can basically cut it short, stick that on there, thread the wire through, and as you heat that, it'll melt on. It's a low temperature joint, but it's good enough for this application. In terms of tools needed for mechanical, we need a T10 Torx driver. Torx driver is a star shape at the tip. It's likely that you already have one of these. If you've got like your computer repair kit, it's definitely going to be one of the bits in there. It's a very common bit, even though it might not appear so. Then we need a 1.5 millimeter hex key. So this is Allen wrench or hex wrench. These are mainly used for the set screws and for the motor mount. 2 millimeter hex key for most of the other screws, including the bed screws, and 2.5 for the larger screws. Relatively easy. I have a set of parallel jaw pliers that are really quite nice for grabbing, holding, and twisting nuts, but a regular pair of needle nose will do just fine. I always like to have a couple sets of tweezers around. I have large fingers and old eyes, so just keep them handy. And you need a Phillips screwdriver when you get to the electronics. Just to continue on with the rest of the tools, because I laid it all out to do all the rest of the videos. Once we start the wiring, you need some actual wire. This is just 20 gauge hookup wire. Almost any wire will work. I like the silicone because the wire is going to be moving with the bed, so it'll last longer. Flush cutters. Cut the wire. I don't feel like we super need them. I really like using a wire stripper, automatic wire stripper. I'll show how it works when we get that video going, but just surprisingly nice. In order to power the system, I have a 5-volt power brick. This is a 5-volt at 6 amps. The reason it's so many amps is 1, make sure we have enough power for the motor, and 2, so we have enough power to add a Raspberry Pi later, using only that one power brick. The nicest part about this is you're plugging it into the wall separately, so there's no need to touch the Prusa Mini's electronics. You could also use a 50-watt DC-DC converter, where you put the 24 volts from the Prusa Mini in, and 5 volts out. And you use this the same as this, where the Microswitch motor and Raspberry Pi would plug in here, and this would just be stealing power from the Pi. I like this because it's nice, compact, and can be mounted on the machine. I like this because it's a much less intimidating option. For building the belt, this 0.2mm thick Kapton film, printed jig to make the belt. You should still fit on. Oh, perfect. Blue tape to get the belt ready. Knife to cut the belt. This is just a razor blade, basically. Scissors if you need them. Very thin PET tape with a silicone adhesive. The silicone adhesive is nice because it doesn't break down over time on the heat. And of course, did I mention you need a Prusa Mini? Hopefully, I did. Oh, one last thing we need. Forgot. If you are going to use the solder shrink connectors, you do need a heat gun. A hairdryer is not going to cut it. They're relatively inexpensive. If you'd prefer to solder the wires on instead, that is totally fine. Alright. Long-winded overview. Want to give beginning folks a quick check on everything that we're using, that we need. I'll make sure to get the tools we have here up on the bill of materials as well. Alright guys, happy printing. See you soon.